sorry, first on your parent function spring semester green chart, turn to the back where there are just a few functions, and we're going to fill out the information for the cubic and the cubed root. So first we're going to fill it out for the cubic. So I usually list kind of 0 in the middle. So we'll go 0, 1, 2, 3, -1, -2, -3, up. So we're cubing these values. So when we cube 0, we get 0. When we cube 1, you get 1. 2 times 2 times 2 is 8. 3 cubed is 27. So when we graph a cubic, it has negative y values, because when you multiply a number an odd number of times, it's still negative. So when you cube -1, you get -1. When you cube -2, -8, and for -3, -27. Bless you. Usually can't fit a whole lot of points when you graph a cubic. Usually just the 3 that are kind of right in the middle where the center is located. So this one's at 0, 0. And then this is my counting pattern that I'm going to use during this unit. So for the parent function, when I move right 1, I go up 1. When I move right 2, I go up 8. And so when I move left -1, it's down -1. And then left -2 is down -1, 2, 3, 4, 5, 6, 7, 8. So you guys have kind of been graphing it with your calculator when we were in the inverse unit. It looks like this little squiggle. And usually if you're graphing it with your calculator, you can see those 3 whole number points, the center, and then the 2 on either side. Its domain and range, it's always going a little bit. So like if I graph -3, it would be down at -27. It's always moving a little bit to the left and a little bit to the right. It's just hard to see because it's so tall. It grows so quickly. The range is a little easier to see. So all real numbers. Your x-intercept and y-intercept are the origin for the parent function. There are some different forms on your parent function sheet. We're going to use H and K form, the first one, to graph with parameter changes today. The second one is root form, but there's 3 roots. And then the last one is in standard form. So it kind of looks like a quadratic, except it has ax cubed. So there's another term. Questions over the cubic function, the cubic parent function? So now we're going to graph the cube root. And you're going to graph both today. So you have to be careful not to get them mixed up. The cube root is the inverse. So if I start at 0, the cube root of 0 is 0. The cube root of 1 is 1. The next point I want to use is the cube root of 8 is 2. And then the cube root of 27 is 3. So it's the inverse. I'm switching x and y. The cube root of -1 is -1. The cube root of -8 is -2. -27 is 3. So my x and y values are switched. So when I graph it, it's not really tall. It's really wide. Alexa. Well, I use this as my counting pattern, but today we might look at cubics or cube roots that have parameter changes. We're going to move the center left, right, up, down, and we might have a different a value, which will make it grow faster or slower, and we might reflect it over the x-axis. So the little 3 points might be going the other direction. But this is just the parent function. Kind of like when I graph the quadratic, 0, 0, 1 squared is 1, 2 squared is 4, and I make those 5 points. 3 squared is 9. I make the 5 points on the parabola, and then you just learn to kind of shift it around your graph. So for this one, we have 0, 0, 1, 1. And so this guy, since it's 8, 1, 2, 3, 4, 5, 6, 7, 8, the cubed root of 8 is 2, it looks like it's really wide. -1, -1. The cubed root of -1, 2, 3, 4, 5, 6, 7, 8 is -2. So this one just is the inverse. So just be careful today when you're graphing, you know which one you're graphing. Domain, all real numbers. And then for my range, again, the next point's going to be -27, -3. So it's going to be going down. You just can't really see it because it's so big. And when it goes -27, 3, it's going up. The x-intercept and the y-intercept are the origin. For the parent function, yes. And now we're going to learn to kind of move it around. Let me warn you, the 2 examples on the notes are harder than anything you have on your assignment. Okay, so don't feel like they're all going to be exactly like the ones on the notes. The notes have more changes than the assignment. The assignment's not too bad. But you might want to look at that green sheet when you're working on the assignment, and it'll kind of help you. So today, our notes graphing cubic and cube root functions. So we're looking at, so this is on your little half sheet. We're not going to do quartic. If we do it, it'll be at the end of the year. We're just doing cubic and cubed root today. So if you switch to your notes, we have that same h and k, or it's like modified point slope, that gives us the horizontal and the vertical shift of the center. So when I'm looking for the center, my center is just h and k. I have to remember that h is inside the parentheses, so insiders lie. So when I'm looking for the center on this one, it's +1, -4. Okay, because that h is lying. So the parent was just 0, 0. But this equation has a shift to the right, 1, and down 1, 2, 3, 4. That's my new center. So it went right 1 and down 4. It also has a dilation in the front. Instead of just being 1, we're multiplying it by 3/2 or 1.5. So you always have to look for a dilation. If I didn't have the dilation, I would be ready to, if this is my new center, up over 1, up 1, left 1, down 1, and I could draw my squiggle. But it has a dilation. So let's go ahead and we'll write our counting pattern in. And this isn't really the points it's going to be on. It's just kind of telling me if this is my new origin, how I move. So we'll kind of use this table. And you don't have to use the tables if you don't like them on your assignment, because some people like them and some people don't. So we are cubing. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, -1 cubed is -1, -2 cubed is -8. But now she gives us a little column so that we could put that dilation in there. So we're going to multiply each of these by, I'll just write 1.5 instead of 3/2 so it fits a little better. So I'm multiplying them all by 1.5. So my new y values, instead of, well, this one always stays the same. So times 0 is 0. Instead of being right 1, up 1, now it's 1 times 1.5. So I'm going to go up 1.5. This way, it's going to be -1.5. On the bottom, 8 times 1.5 is 12. Good. And up here, -12. And so when you're graphing these, you're not going to be able to fit a whole lot of points on your graph because they're so big. So I really just want to go to the center and then right 1, up 1.5, left 1, down 1.5. I think I might be able to fit the 212. So from my center, right 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It'd be like up here. So it doesn't really quite fit. But. So it's going to look like this little squiggle. So that's how I graph it with the parameter changes. Now these aren't going to be the points if you were to use your calculator that are on your calculator. You'd actually see, 2, -2.5, 1, -4. But we're talking about graphing with a pattern, graphing with that parameter changes. Your domain and range is never going to change, no matter what you do to it. Your domain and range? Yeah, because if you write it over and over again, it only takes a second, but you'll remember it. And I bet that'll be on your unit test. Kind of like in inverses, I always said it reflects over y equals x. Reflects over y equals x, because I wanted you to remember that. Okay, because you should be able to write the domain and range. So if you do it a lot, you'll remember. That was a cubed. Now we're going to do an example of a more difficult cubed root. So I have to be careful because my counting pattern's different. So when I'm doing cubed root, I want to use 0, 1, and 8. The cubed root of 0 is 0. The cubed root of 1 is 1. The cubed root of 8 is 2, -1, and -2. So you always be careful and make sure you know which one you're graphing. I think that they're all together on the front and the back of the worksheet. So this one I have to look for the center. I want to pull the h out from under the cubed root. That's where the parentheses would be, but they don't really write them on there. So the center is at +2, and then there's no k value added on the end, so that just means 0. So my new center is here at +2, 0. Now it has a dilation, so I moved it right 2. And it has a dilation times -1/4. And so you could describe it as a reflection over the x-axis. Because the negative is going to reflect it over the x-axis, but I'm also multiplying it by 1/4. So if I go through and multiply my y values by -0.25, and I'm just going to use the table if it helps me. For 0, it's still going to be 0. 1 times -2.5, -2.5. 2 times -2.5, -0.5. This way, my negative values are going to turn positive. -1 times -2.5, +2.5, and then +0.5. So if I reflect it over the x-axis, instead of going right 1, up 1, mine's going to go right 1 and down. So those 3 little dots aren't going to look like that anymore. They're going to go the other direction. So if this is my new center, I'm going to go right 1, down -0.25. Left 1, up +0.25. And I might be able to fit -8.5 on there. So from my center, -1, 2, 3, 4, 5, 6, 7, 8, +0.5. The other points aren't going to fit. So I kind of compressed it. It's a little bit, it's not as tall. So on the other one, when it wasn't reflected, the points increase from left to right. See how they're in that order, increasing from left to right? And then when you reflect it, your little 3 points in the middle are going to decrease from left to right. Your domain and range isn't going to change. And so you just have to be careful if you're graphing cubed root, it's wide, and if you're graphing cubed, it's tall. What do you think? Questions? These are the hardest problems you'll have. You don't have problems like this on your homework. Your homework's pretty easy. It's pretty much just moving the center and graphing the pattern. I think there's one dilation and one where you have to write the equation, but that's about it.